In this lesson, we're going to continue talking about ionic compounds, but we're focusing on ionic compounds that have polyatomic ions. So we're going to learn how to write chemical formulas for them, as well as name them as well. So what are polyatomic ions? So polyatomic ions are made up of more than one atom that acts as a single charged particle. So an example of a polyatomic ion would be NO3. So this is just one of the few that we are going to learn today. And NO3 as a whole is a polyatomic ion. And I show this by putting a bracket around it, as well as identifying its charge. So NO3 has a charge of -1. So what this is telling me is that this entire particle, so with 1 nitrogen, 3 oxygen, they're acting together, and that entire ion has a charge of -1. And this charge doesn't apply to just the nitrogen or just the oxygen. This entire thing together has a charge of -1. So here are the 5 main polyatomic ions that you might already know, but you're going to need to know. So the first one we've already mentioned is nitrate. So as I talked about already, nitrate has an ionic formula of NO3, and its charge is -1. So when I usually write it, just like I did earlier, I would write NO3 bracket -1. And this -1 is sitting on top, just to show that it is the charge. The next one that we are going to be talking about is carbonate. And carbonate is CO3, and it's got an ionic charge of -2. Next is chlorate, ClO3, and it's got a charge of -1. Sulfate is next, SO4, charge of -2. Phosphate is PO4, and it's got a charge of -3. Now, there's an easy way for you to remember all of these pretty quickly, and that is based on the saying. So the saying is, Nick the camel had clam supper in Phoenix. So you don't have to use this to memorize it, but it is very helpful if you're one of those people that would like to remember this. So why this helps is because there's a few things that makes polyatomic ions harder for us to remember, right? One is the number of oxygens, because that's different for all of them, and there's no pattern per se. And the charge is another one of those numbers, right? So if you remember these words, you can remember the number of oxygens as well as the charge. So if you take a look at the vowels tell you the charge for each polyatomic ion. So Nick, we're talking about nitrate, has 1 vowel, which means the charge is 1. Camel has 2 vowels, which means the charge is 2. Clam has 1 vowel, charge is 1. Supper has 2 vowels, charge is 2, and Phoenix has 3 vowels, which means the charge is 3. On the other hand, if you take a look at the consonants, so those are the letters that are not the vowels, you would be able to identify the number of oxygens. So Nick, there's 3 consonants, so 3 oxygens. 3 consonants here, 3 oxygens here, same as this. Supper has 4 consonants, which means there's 4 oxygens. Phoenix also has 4 consonants, which means there's 4 oxygens in this as well. Okay, that's just an easy way for you to remember those. So these are the 5 main ones, and in our next few lessons we're going to come back to these polyatomic ions because there are different variations for each of these as well. And there are another set of other polyatomic ions that you will see quite often. So I'm just going to go through and have you fill in these as well. So cyanide, the ionic formula is Cn, and the charge is -1. Acetate is CH3COO -1. Dichromate is Cr2O7. The charge is -2. And oxalate is C2O4. Charge is -2. So these are, other than those 5 main polyatomic ions, you're going to see these quite often. I want to draw your attention to ammonium. This is the only polyatomic ion that we're going to see that has a +1 charge. And this becomes important. When we do our examples, we'll do an example with one of these, but it's important for you to know that ammonium is the only polyatomic ion that has a positive charge. Everything else has a negative charge. So having looked at our polyatomic ions, let's put this into practice. So what does it look like when we write a chemical formula for it? The rules are exactly the same as the ionic compounds. I think that people just can get confused because the polyatomic ions are a few different elements put together. So once you understand what a polyatomic ion is, this becomes pretty easy. Okay. So just like we would for any other ionic compound, we have to list out what elements are here, right? So magnesium is Mg, and phosphate, I know that's a polyatomic ion, so I'm going to write PO4, and I'm going to close the brackets and write the charge for each of these. So PO4, phosphate, if you remember, Phoenix has a charge of -3. And magnesium is in group 2, so that has a charge of +2. And just like we did for the other ionic compounds, I am going to crisscross these numbers. So Mg3, PO4, 2. And this bracket is very important because it shows how many of the PO4 there are. Right? So if there isn't a bracket around any polyatomic ion, you know that there's just one of them. So right now, the formula is Mg3PO4 2. And that's it. That's our answer. I just want to draw your attention to the fact that these two numbers are different. So PO4, phosphate in itself is PO4. So this 4 should not be treated like we do these numbers here that have been crisscrossed. The PO4 is part of the identity of what phosphate is. So just make sure that you don't get confused with all of the numbers here. But this is the chemical formula for magnesium phosphate. All right, let's try another one. So similarly, I'm going to write out the element symbols. Cu is copper. Carbonate is CO3. Let's write the charges for the ions. So CO3 is -2. And copper, it's a transition metal, so I don't know its charge from the periodic table. However, in the name, it's stated the charge, so I know that the charge is +1. All right, let's crisscross. I'm not going to change colors here. I feel like you know what's happening. So after we crisscross, we would have Cu2. And now the 1 is what's coming on the other side of the CO3. And just like I mentioned earlier, we only put the brackets for polyatomic ions if there's more than one of it. And because there's not more than one of it, I can just leave it as CO3. So this is my formula for copper 1 carbonate. Okay, let's try our last one. Calcium is Ca, sulfate is SO4. Let's put in our charges for each of these. Calcium has a +2 charge. Sulfate has a -2 charge. So after we crisscross, both those 2's are going to go to their respective places. So Cu2, SO4, 2. Now, I told you that the rules for ionic compounds still apply to these compounds, right? So if you take a look, the charge that both of these ions started with are the same. And what happens when we usually have a scenario like that is that we have to reduce, right? So we've got a 2 here and a 2 here. I've got to reduce these. Now, you might be wondering why the 4 is not part of this reduction. Remember that the 4 is part of sulfate. Sulfate in itself is SO4, so it's not going to be involved in any of the reduction that we're doing. Okay, so I've got 1 calcium Ca, and I've got 1 sulfate, right? And because there's only one of the sulfate, I'm not going to put the bracket around it anymore. So SO4. CaSO4. And that is the charge for calcium sulfate. Sorry, chemical formula for calcium sulfate. Let's do the opposite. Let's write the names for these compounds. So an easy way for you to identify whether or not there is a polyatomic ion in the compound that you're looking at is to see if there's more than 2 elements present. So if you have something like NaCl, you know that sodium is an element and Cl is an element. So because there's only 2 elements, you can go on naming it as if you would any other simple ionic compound. However, in this case, anytime you have more than 2 elements, you're looking at least 1 polyatomic ion in there. So I know that Na is 1 element, and I know that oxygen is 1 element. I know that hydrogen is another element as well. So I just have to look at my chart that I previously looked at earlier with you guys, and see which of the polyatomic ions are present here. In this case, I know that OH is a polyatomic ion hydroxide, and that's what's present here. After you identify it, it becomes very easy. You literally just write the name of the first element, which is sodium. And then you write the name of the polyatomic ion, which is hydroxide. And that's it, sodium hydroxide. You don't have to change the ending at all with polyatomic ions. You just write the ion name as is. I'm just going to cross this out, just not to confuse anybody. Okay? All right, let's take a look at another example. So as you can see, I know that there's way more than just 2 elements in this, so there's got to be at least 1 polyatomic ion. After looking at my list, I know that NH4 is 1 polyatomic ion, and ClO3 is another polyatomic ion. So I can just name them. NH4 is ammonium, and ClO3 is chlorate. So together I've got ammonium chlorate, and that's it. All right, let's take a look at this last example. Again, more than 2 elements. Looking at my chart, I know that SO4 is sulfate, that's a polyatomic ion, and I know that Pb is lead, so I'm going to write lead sulfate. However, unlike the other examples that we looked at, there is something specific or unique about lead, and that's that lead is a transition metal. So because it's a transition metal, I'm going to have to specify its charge. So if we take a look at this compound here, I'm going to think backwards, if you will. So I know that because there's no bracket around my sulfate, that there's just 1 sulfate here. And because there's no number after the Pb, I know that there's just 1 lead here. And if I were to reverse these crisscrosses, or work backwards, PbSO4, because there's no number here, I can maybe say that Pb has a charge of 1. And because there's no number here, I can say that this has SO4 has a charge of -1. However, I know that that's not true. Sulfate doesn't have more than 1 charge. It just has 1 charge, and that 1 charge is -2. It's not -1, it's -2. So what might have the charge of lead had to have been for both of them to end up with a number 1 beside it? the answer is that both of these ions had to have the same value in charge for them to have canceled out. So if we know that sulfate has a charge of -2, we know that lead has to have a charge of +2. And that's it. So that tells me that my name is lead 2 sulfate. And that's it for this lesson. Bye.